Good day to all of you. In today's session, we shall discuss about what is graph, spanning tree and minimum cost spanning tree. Let's start the session. First, we shall discuss on what is graph and spanning tree. Next, we shall move on to minimum cost spanning tree. A graph can be defined as set of vertices connected by edges. So, this figure shows an example graph. It has vertices A, B, C. These are called as vertices. They are actually data fields. Vertices are also called as nodes. The lines connecting these vertices, they are called as edges. Spanning tree is a subgraph that contains all the vertices of a graph, doesn't have cycles, and it cannot be disconnected, has a minimal set of edges, and may or may not be weighted. A single connected graph can have multiple spanning trees. Okay. Now we shall see to these points. What do they mean? So if this is the given graph, for that one spanning tree is this. So in the given graph there are 1, 2, 3 vertices. Its spanning tree also has 3 vertices. So this spanning tree will be the subgraph of given graph and it will have same number of vertices as the given graph. So spanning tree is the subgraph. It contains all the vertices of a graph. That is first point. The spanning trees do not have cycles. See, graph means it may have cycle. So if you start from this vertex through edges, you can come back to same the vertex. There is path. But in trees, there is no cycle. So if you start moving from this vertex through edge, you will go to A, then you will go to C. There is no edge and hence there is no cycle here. From C to B, there is no path. It cannot form a cycle. So that is what is this second point means. And it cannot be disconnected. Disconnected in the sense, so this subgraph is connected, means there is connection between all the vertices. So A is connected to B through this edge. A is connected to C through this edge. B is also connected to C. From B to A there is one path. Through that edge we can move. Then through this edge, that is AC, we can reach C. So this is how through these two edges B is connected to C. So all the vertices are connected. So spanning tree subgraph, it will always be connected. It cannot be disconnected. So this is not disconnected. It is connected. So disconnected means, see to this figure. The same three vertices 1, 2, 3. These two are connected, but this vertex is not connected to these. So this is called as disconnected subgraph. Spanning tree cannot be disconnected subgraph. It will always be connected subgraph. Spanning tree has minimal set of edges. So this graph has 3 edges, 1, 2, 3. So it's a spanning tree. So it's a subgraph which is a spanning tree has only 2 edges, not 3. Minimal edges. So with only 2 edges, all the vertices can be connected here. So A is connected to B, A is connected to C. As already told, B is connected to C through these 2 edges. So only 2 edges are more than enough to connect all the vertices. So all the 3 edges of the given graph, they are not used here. Okay. So that is what is meant by spanning tree has minimal set of edges. Next point is spanning tree subgraph may or may not be weighted. So if the given graph is not weighted, what subgraph spanning tree we find? It will be unweighted. Then if the given graph is weighted, what spanning tree we find for that? That subgraph will be weighted. So spanning tree subgraph may or may not be weighted. So what are these weights? They are the costs. So to understand cost, this A, B, C. they may be houses. Then this is the road between A and B houses. This is the road between A and C houses. This is the road between B and C houses. So if this 5 is the cost means, say for example, 5 crore rupees is needed to construct this road which connects house A and B. So that is this cost. Similarly, here 4 and 8. So such a graph with cost, what is written, that is called as weighted graph, and subgraph spanning tree, what we find for that, that is called as weighted spanning tree. So if this is the given unweighted graph, what subgraph or spanning tree we find will be a unweighted spanning tree. If this is the given weighted graph, what subgraph or spanning tree we find for that, that will be weighted spanning tree. So that is what is the meaning of this. Spanning tree subgraph may or may not be weighted. So another important point is, in case of connected graph with n vertices, the number of edges in its spanning tree is equal to n minus 1. Suppose this connected graph, if you take, graph is set of vertices and edges. Connected graph means all the vertices will be connected. So if number of vertices, that is n, is 3 here, then number of edges in its subgraph, that spanning tree, will be n minus 1, that is 3 minus 1, that equal to 2. So this is a very important point that we have to remember. Okay. Next we'll see to this point. A single connected graph can have multiple spanning trees. So to see to the point that a single connected graph can have multiple spanning trees, we'll take the same example. A complete undirected graph G can have a maximum n raised to n minus 2 number of spanning trees, where n is the number of nodes in the given graph G. So this is the formula that is used to find how many number of spanning tree subgraphs will be there for the given graph. So for that, consider a complete graph G with 3 vertices, that is this graph. N is 3, means number of vertices in this graph is 3. It is a complete graph. Complete graph means all the vertices are connected to each other. So for this complete graph with 3 vertices, that is n equal to 3, the total number of spanning trees that we can obtain is, as per this formula, n raised to n minus 2. So n is 3. 3 to the power of 3 minus 2. 3 minus 2 is 1. 3 to the power 1 means 3. So the total number of spanning trees for this graph will be 3. That we shall see next. So this is spanning tree 1, second spanning tree, third spanning tree. These are the 3 possible subgraphs, spanning trees, for this given graph. If you recall the point, if in the given graph, if there are n vertices, the number of edges in each subgraph, that is in spanning tree, it will be n minus 1. So here 3 vertices are there. So in their spanning trees, definitely there will be only 2 edges. So 1, 2. There are 2 edges in the first spanning tree, and similarly in second one and the third one. Now we have understood what is graph, then what are the spanning trees, and for the given graph how many spanning trees can be obtained. So next we shall see what is minimum cost spanning tree or minimum spanning tree, that is MST. Okay. So to understand what is minimum cost spanning tree, we'll have to consider weighted graph. So let us take this example, that is the same example what we have discussed so far. Then the possible number of spanning trees is 3. 1, 2, 3. So what is minimum spanning tree or minimum cost spanning tree? So it states that spanning tree with minimal total cost is called as minimum spanning tree or minimum cost spanning tree, that is MST. Okay. So here out of these three spanning trees or subgraphs possible for this given graph, so here the total cost is 5 plus 4. So to construct this road, 5 crores plus this road 4 crores, totally 9 crores is needed. So total cost of this spanning tree is 9. Similarly, this is 13 in the second case, 12 in the third case. Where total cost is minimum, so this 9 is the minimum cost. 13 and 12 are bigger values, so 9 is the minimum. Hence, this spanning tree is the minimum cost spanning tree or minimum spanning tree MST for this given graph. So, what is minimum cost spanning tree? For the given graph, that spanning tree which has the total cost or cost of the subgraph minimum. So, that spanning tree subgraph is called as minimum cost spanning tree for the given graph. Okay. With that, we come to the end of today's session. In today's session, we discussed about what is graph and what is spanning tree, and for the given complete connected graph, how many spanning trees can be constructed and how many edges will be in each spanning tree. Then what is minimum spanning tree or minimum cost spanning tree, and for the given graph what spanning trees subgraphs we find which is the minimum cost spanning tree. So these are the points that we discussed today. I hope you understood. Thank you.